Algebra 2, Chapter 3.3, exercises 8 through 10. This section in the book has to do with fitting quadratic functions to data. And I'm going to do in this exercise set the odd number problems, odd problem 9, and then one more which is called our lesson performance task. And here we go, problem 9, multi-step problem. A school is making digital backups of 16 millimeter educational films, reels in its library's archives. The table shows approximate run times of films for a given diameter of film on the reel. It says use the quadratic regression feature on a graphing calculator. Find the model for runtime t as a function of diameter d. And here we have at the right a table of diameter on the left, our independent quantity, and the dependent quantity runtime on the right column. And so we're going to go to our graphing calculator, in my case a TI 84CE calculator, and I have previously entered the data, and to get to where we enter that data we go to stat edit, which is just stat enter, and we enter the data. So here under L1 I've entered the independent quantities, and on L2 I've entered the corresponding dependent quantities. And to get this quadratic function, what we do is we go to stat calc, so I'm just arrowing once to the right, and go to 5 for quadratic regression. We press 5 and then we press enter until we get a calculation, and in this calculation we get y equals about 0.40, it looks like 0.401, and that's going to be x squared plus 0.792 x minus 4.93, and that's some rounding to hundredths place here, but so let's go ahead and put this in our calculator. Let me just write it down first. Okay, what we'll say it's going to be t, we'll say t is dependent on d, so we say t is equal to 0.401 d squared plus 0.792 d, and finally we have minus 4.93. And then it says, what does the model predict for runtime of a film reel with a diameter of 15 inches? Let's go and enter this in our calculator here, and here we have it. We go to our function editor and put 0.401 x squared plus 0.792x minus 4.93, and then if we graph this in our calculator we get a standard view screen like this one. Let's go ahead and put the data here so I can see it. We go to y equals, I'm going to go to plot 1 so we can actually see our points, how they trace. So we can see a few of those points, but not enough of them. So let's go ahead and restrict the scope of this calculator here. And to do that, let's get our window. I'm going to go x min, I'll say -1 to x max of well, we have data 14, but we know we need to get to 15 for what we need to really see. So I'm going to put 16 right here. And for us y minimum, I'm going to put -5. And y maximum, I'm going to put 120. I'm going to y scale by 10. And here we should see better. Yeah, that looks better right here. So let's we can see that the data, the points, fit fairly closely here. So let's see what question we're asked again. It says, what's the model predict for a runtime with a film reel with a diameter of 15 inches? So we can do that a number of ways. A good way to do that is we can just look at the graph. We can count to 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15, and these are by 10s up to 120. So it looks like we're about to 95. Another thing we can do is we can get exactly by going to second trace, and we can enter value. And we enter the value of 15 and see what we see here. We get an exact number, exact answer of 97.175. So 97.175, that's going to be minutes. It says use the calculator to graph the data points, which I've already done, run the regression model, and make a rough estimate of the X-Intercept. What is the X-Intercept? Well, let's see what we can find here. Go to the calculator. The X-Intercept is where the graph crosses the x-axis. I can find that by going second trace. And well, there are a number of ways we can do that. I'll show you one way first. We can get to pick 2 for 0, and we have that question left bound. So now we can arrow over to the left. Now it's going to take a considerable amount of time since the cursor was way over to the right of the curve. I'm going to show you a quicker way to do it shortly. It says left bound, so we go all the way over. And once we're to the left of the X-intercept here, we can press enter. Then it asks the question right bound. We arrow to the right until we're to the right of the X-intercept and press enter twice. We get 2.66. So let's see, 2.66, and that's going to be inches. And to get it more quickly, I'll show you how to do this. If you go to the function editor, under Y2, we can press enter 0, and when we graph both these functions, we have this red horizontal line along the x-axis. We can go second, trace 5, enter, 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 and we can get the same value a lot more quickly, efficiently. So that's another way to get there. What does that mean? Well, this means that the diameter looks like the runtime is 0 when diameter is 2.66 inches. So it shows probably the diameter of the blank reel or hub of the reel is about 2.6 inches or 2.7 inches. Okay. And then part D, on the same screen, graph the horizontal line y equals 60. Use the calculator to find the intersection of the line with the model. What prediction to the model, by the model, does the point of intersection indicate? Let's go to see what we have here. I'm just going to go and change this 0 I did down here earlier to 60. And we graph both curves. And we're going to go to second, trace 5. Enter, enter, enter. And what does this tell us? Well, 11.78. So we get X equals 11.78, and that's going to be inches. So what does that mean? It means that the diameter, which is in diameter, yields 60 minutes or 1 hour of run time. Okay, so we have that there. Now next we're going to go to, we look at problem 10. We're not going to do that one. That's a kind of a practical question. I'm going to look at this last one here. Lesson performance task, which talks about the ozone layer over the Antarctica as temperatures plummet. And we're asked questions about finding a quadratic function that roughly models the changes in area. So what I'm going to do is just show you the process of entering the data in the calculator, since I didn't do that right at the beginning. I'm going to go to second, not second, I'm going to go to stat, edit, and I'm going to put in new data. And to do that, I'm going to go up to L1 and press at the top, press clear and down arrow. Data gone. And now I'm going to do the same thing, L2, press clear, down arrow. I'm going to enter the data. So, for this, I'm entering 0, 17, 31, 47, 61, 78, 92, and then for output data, I'm putting, which would be the area of the ozone hole, 4, 18, 23, 24, 22, 17, 10. So we make sure we have the same, we have an output for each input value. If not, we would get a dimension mismatch error message and have to figure things out. And again, if we take the, we can check the graph here to get commensurate data. Looks like we're going from L2 output, input up to 100. So I'm going to go 0 to 100 here by tens, and then I'm going to go for output values. I'm going to go 0 to 30, we'll say. And now I'm going to go by ones. So we see, if we graph, this is what we get. I'm just going to clear. So we just see the points right here. And if we go to stat calc 5 and enter all the way down, we get this data here, and we can press this data in and it would match pretty well the curve. We can take care of that in one way I haven't shown you yet. If we go to stat calc 5, we can go down here to store regression equation, and we could put y1 right here. Let's see if I can do that. Let's see, y1. I don't know if I can. Stat calc 5. Store y1. To do that, I think we go to vars, yvars, function. It says y1, press enter, and now we can go and calculate. And what this does is it places the equation right here, pastes it directly into our function editor, and we can graph and see the match that we have, which overall is a pretty good match. And then we can answer questions about this. And one of the questions is, at what time will the ozone layer be down to, will disappear? So if we go to window, I can make my X max a little greater. We might be able to see, and we could find the number of days, because the days would be here on the x-axis. Anyway, that's as far as I'm going to go on this today. I hope this has been helpful. Good luck, and thanks for viewing.